In this video, we'll be dealing with circular columns. So this video is a follow-up on the previous video. If I go transparency mode, Control 2, and we have a look. So in the previous video of this chapter, we did these rectangular columns in a few ways. So in this, we're going to do circular columns in a similar way, but again, there are some caveats on how to use components versus rebar sets versus rebar groups. It's pretty much a totally different to the rectangular columns again. So with that in mind, let's just get on with it. So I'll go Control P, and I will also get a view on grid line 2. So if I go to view list, I will extract grid line 2, and then also I will do a plan on 0 so we can just see the plan. And I'll just tab back to my rendered view, and in this case what I'm going to do is I'm going to grab this column, and I'm going to say right click, and I'm going to say fit the work area in all views. So all views will then have only this little portion. So what we can do as a start, and I'll use the rendered view for this initial column, is we'll start again with custom components. So if we head over to our applications and components library, and in our search bar we type REIN for reinforcement, and we scroll down a little bit, we'll find a round column reinforcement 82. It's sort of the sister component to 83. So if I click on that, select the column, it will then reinforce it with some default settings. If I just double click on it again, let's just load the standard modify. Okay, yep, that is definitely the default setting. So let's see how we can improve on this. And for this, I'll click on the component to load double click on the component to load the dialog. And then I will flip over to the plan view, which is this one. And let's just start, I think in this one, let me just see the depth of view. So it's up to 3000. So let's just make it 500 for now, modify. Okay. So that is what the, oh, it's cranked and it's hooked. Okay, I see. That is what the default is at the moment. And as you can see, we've got 3 6 bars. So if I double click on this to activate that, let's go and look at the main reinforcement first. So in this case, what I'm going to do is I am going to say that we, first of all, I want 8 bars in this configuration, 8 bars. And the bar I want is an N grade 20, but not a tie. You don't use tie for main bars, you use mains. And then the class I'm going to make 4, which is our blue color again. And then I'll just stick with that. The hooks, I'm just going to say no hook. Actually, let me just clear these values and say no hook there, and say modify. Okay, that looks far better. So now we've got 8 bars, and we have selected a extension of, if we go over to the let me just click on this, go over to the elevation. What we've done is we've selected an extension of 1000, which is on the top of the column, as you can see there. That means that from there, from the top of the kink, the column, I beg your pardon, from there, which is the top of the column, to there is 1000. So if we still, let's address this this crank first, and then we can make sure we've got the extension right. So in the crank, what I'm going to do is, so I want the crank to start at the top of the column, which is the soffit of the slab. So that value I'm going to make 0. And then the crank part's going to be 200, because again, it's bar diameter times 10 as a rule of thumb here in Australia. So we'll do 200 there, and I'll say modify. So you can see now we get the crank from the bottom to the top because it's a 200 slab. And then the actual crank dimension itself, this here, I do want to select not center to center. I do want to select outside to outside, and the value that I'm going to use is 2 times the bar diameter, which is 23 is the bar diameter. Remember, that's the actual. The nominal is 20, but the actual is 23 because it allows for the deformation, the ribs on the side, and that's what we want to deal with when we want to fit one bar over another bar. So it's 23 times 2 is 46. So 50 is probably good enough, but I'm just going to be precise. I'm going to say 46, so you can see how that adjusts. And then the extension, it gives the extension from the top of the column. So let's just see where that, in terms of actual dimension, if that 1000 is measuring from the top of the slab, that straight part, or is it actually measuring from the bottom? So if I hit my F button and I go from, let's say, just bottom of the slab to the top of the column in there, we can say that, see that the Z, this, forget about the actual dimension, that's the slope dimension, the Z, which is the Z on the axis here, is 1,000. So it's measuring from the bottom. So we need to, if we want that to be 1,000, we really need to add the 200 for this as well then. So with that in mind, we can click on it, go back here and say this is 1,200, and then say modify. That will then give us a lap of 1,000 millimeter, and we can check it by again just hitting F. From there to there, go back there, and then we have 1,000 as our Z, which is now correct. Okay, click on it, and then next thing. So we've got the verticals pretty much sorted out. All of these are as per, again, below we don't have any values. If we move on to the ligatures, well, first of all, I just want to make sure that in here, we're actually dealing with a 25 millimeter cover, modify. And then at the bottom, the main bars are stopping 25 short. I actually want a little bit more because we want to allow them to get a kicker in there. So I'm going to add 50 mils there. It's going to pull the bars up a little bit. So that's pretty good. So now the next thing we need to do is to actually look at the ligatures itself. So if we go over to stirrups, again, like before, we've got a few options here. We can either go spiral, modify, it will give you a nice spiral. And this time it actually is spiral because it's a circular column. And then we can have multiple spiral. In other words, in this case, it's going to give us 3 spirals because we have 3 zones defined. So if I go modify, how does that look? So if we look at this, we can actually see, if we just zip around, there's a spiral stop start, which is spiral 1, spiral 2. And if we go there, spiral stop start, so it's 3 spirals. Again, when you do that, you can define 3 different sizes. That's not what we want. We want actually ligatures, and we want one set of ligatures all the way through because we are going to try and do some interesting stuff with it. So if I look at this, the first thing I want to do is at the bottom, I want to make sure that I'm using 100 spacing as we did in the rectangular columns. And the number of bars we want there is 10 because we want to cover our splice of a meter. So that's going to be 10. We're going to have our main spacing at 200 as per the previous video, 200. And then on the top, instead of having 5 bars, we want 4 bars. And instead of 100 spacing, we want 50 spacing to get them really close up. So that's pretty much what the engineer wants. So if we just double click on that again, just to activate it, there are some other choices here. The one is the shape. So if I click on this sort of hexagon shape and I say modify, if I just rotate, you see that it sort of gives a kink around every bar. If I increase the number of vertical bars, the number of kinks in the stirrup will actually increase, and it gives us a lap on the side. If we change this to a ear, modify, it will give us an ear there. But again, it's a very unconventional bar, and to be quite honest, I've not really seen them use this in normal casting situ applications. If we go to the default, which is just a circular modify, that is pretty much the norm. And in this case, it's just covering a lap. Now the lap can be defined as a length or an angle. So if we say a length of 500 millimeters here, modify, it will increase the lap to 500. I think what we can do now is just move on to the attributes. Now, because we specified one single type right through, if we go on attributes, the others will be grayed out. And in here, we can actually pick the type of ligature we want to use. So we want an R10 as a ligature as before, and that will change it. And also the class will change to 5 to our blue color as before. And then the top reinforcement, again, it's anti bursting steel. So you know, if you've got a laminated elastomeric bearing you put on, yeah, or something, you might require this reinforcement, but in normal columns, not really. That's the bottom detail. The advanced main bars again allows you to you know, slope a column, cut away certain bars, and so forth. Again, not necessary in this application. And then lastly, again, we have the option of rebar assembly, where if this needs to be a fabricated cage, we can select it as a fabricated cage, Tekla 2022 upwards, very important. But that's useful if you want to send the cage to a assembly drawing, like you want to create a drawing out of that part as an assembly. That pretty much concludes this. Now, before we move on, I need to highlight a few things. The first thing is this is a lap. A lot of times the engineer would specify a hook around these bars and a hook around here. Now there is no option yet to do that. As you can see there's no option. The only option you've got for a hook is this one, but then there's no lap. And on the circular ones, there's no hook. Now you could argue that if we just get out of this component quickly, you could argue that we could go to our in-object settings in the component, click on this, and then hover over to the Properties tab, and just go and add a hook on this rebar group and say modify. And just like that, we've got a hook. The issue with that is if we go back to component mode, we double click on this. Now it's loaded all its own defaults. We can even say get if we want. If we then say modify, the hook is gone again. So there is no point in doing that as long as it remains a component. The only alternative to solve that is to actually explode it. And once you've exploded, you lose the power of the component. So that is one sort of limitation of this particular component, that in this part of the world, Australia, definitely, it's pretty common to specify a circular ligature with a hook at the end. But we'll deal with that as a second column where we're going to actually detail it manually, and we'll deal with all of those. Now, once we have that, what we could basically do is just go back to our component catalog, click on our circular component, and then click the top column, and that will instantly reinforce the top column with the same settings we had below. And as you can see, they fit really nicely in there. There's no clashes there. Really fits nice. The only difference is we need to revise the top. So if we double click on the component to bring up the dialog box, we can then go to the top detail. So for the top detail, basically what we can do is we can zero this out, modify, and it will give us a broken bar. If we delete this, I think if we just clear those and say modify, it still gives us because of this. So if we delete this as well, modify, there we go. Now we've got our, because there was a crank value in here. So if we delete, just clear that box, we have no crank in there. That gives us a straight bar. We still have the extension, it's too long. So in this case, we want 150 into the slab. If we say modify, that gives us 150. Now, in terms of the hooks, we have two choices here. First choice, we could just add a value of 250 in there, modify, that will crank them to the outside. If I click on it, home, make it a negative, modify, it will crank it towards the inside. So if I just delete that and say modify, we have no crank. The second option is under hooks at the top. There's hooks at the top and hooks at the bottom. If we say hooks at the top, we can say the hook type we want is a 90-degree hook. The length is 150 millimeters and the bending radius is 50, because that's sort of the standard hook from the catalog. If we say modify, that will give us a 90-degree hook bent inwards. To get it to bend to the other way, we can just say it's minus 90 degree and say modify, and that will be outward. So that's the two options we have in terms of the ending. It's also pretty much concludes the component part of it. So if we go back to our uh, rendered view and we just say entire model, and this time we select this column, right click, work area in all views, so we only see this column. What we can do then, if we go back to our plan, this is our plan at level 0, for instance, we can start manually modeling this column. And what I'm going to do with this column is I am going to start by putting in the verticals first as a manual bar. So if we go to the elevation on this, there's the elevation. We can then hover over to the rebar tab. Again, we go single bar. And under our properties, we can make sure that we load a N20 main from our catalog, set our class to our 4 again, and then leave the hooks. And on these, again, if we work with single bars, I like to clear them all. Well, actually, they should be 0, just to 0 them all. And then I can start drawing the bar. So pick the reinforcement part or the part to reinforce, it's the column. and then we need the shape of the bar. Now it's going to draw the bar in this shape that or this plane we see now on the screen. So if I click at the bottom and I click at the top of the column, that's the bottom part of the leg. Now the next node, although I'm not actually drawing a crank because I want a dimension, I want to shift them with dimension, I can just enter a node by clicking to the top of the slab and then extend until I have a value of 1,000, because I know that's going to be my lap. Over there, click, and then middle mouse. That will give me a bar, and as you can see, we do have the handles everywhere we need handles to be able to shape this bar properly. Now that pretty much concludes the input of the bar. So if I select the bar, holding my alternate key, select over those two handles, I can then say right click, move special in a linear direction, and then in the X negative, we want to move it a bar diameter which is 23. So if I say minus 23 and I say move, we now have our crank bar. And because we only select those two handles, these two remain where they are, it forms a perfect cranked bar. Now what we need to do is just to look at the cover. So if I click on the bar, you can see it's pretty much centered. If we look at the top just quickly, it's pretty much centered on the outside of the column. Now the dimension we are interested in is the on-plane setting. So if we say we need 35 millimeters, which again, it's the 25 color cover plus the 10 millimeters of the ligature. If we need 35, it puts it on the outside, which we don't want. We want this to be a negative value, and that will bring it to the inside. And now that in terms of the elevation, that bar is in the right spot. Now let's just flick over to the top, and I'll unselect. And in terms of plane, this bar is also in the right spot because it's still on plane. If I click here, you can see there's the plane. It's still on plane, but it's offset. Well, it's on plane, but it's in the middle of the from plane, but it's 35 millimeter off on plane. Sorry, I stumbled a little bit there, but that's what I mean. I mean, this from plane setting is this little magenta line. You see that it captures the shape. That should always be 0. And then the on plane is the cover from the outside of the concrete. Now what we need to look at is just, if we go back to elevation, is the bottom. Now remember, we want 50 millimeters so they can fit in a kicker at the bottom here. So that will be the start of the bar. So this is star. So in here we want 50. If I say modify, pulls the bar of 50. And then on the top, we actually want the full cover. So we want 0 on the top end, no cover there. So that pretty much fixes up that bar. Now if we go over to the plan, what we can do now is we can click on the bar, right click, and say copy special, rotate, and just make sure that your XY is actually in plan here. And then we click on our grid to establish our rotation point. And then the number of copies is, we want 8 bars, so we want an additional 7 because we already have that one. And then the angle, now if we take 8 bars, 360 degrees divided by 8, we get 45. So if I say 45 degrees there, and I say copy, we get our 8 bars. Now, this is not, although I've shown it, it's not the recommended way. Why? Because we are losing change management a little bit here. So if I click on this bar, for instance, and I increase the cover to say, for instance, 70 millimeters, enter, it moves that bar, but those stay the same. They never changed. So if I just undo that and I undo the copy again, we're left with that bar. The recommended way in this case to have some sort of automation going is to go to our applications catalog, and instead of typing in you type in array. And then what we can do is we can double click on the array tool. And then, well, I'll show you what happens if we just use the standard. The Tekla asks to copy the object, so we can just apply, okay, the object to copy. We click the object and then middle mouse button. Then Tekla asks for origin point, which is the grid line. And then Tekla asks for the direction of the positive X. Now that's the positive X, so we'll just click that end. And then the positive Y. Now Y is up, so it's that end. And instantly it will copy that value. Now, if we click on this little M or on the bar, we can see that we're using an angle of 45, but we're only asking for one extra. So if I change that to 7 and I say modify, we then get all eight our values. Now, obviously, this is recommended. Why? If I now go to this bar and I change the cover to say 70 again, like we did before, it instantly applies it to all the other bars. So you've got a bit of automation there going. So we'll just change that back to 35 what we want. So I always recommend if you're working with single bars and you want some sort of to use the array tool, it's quite useful. Now that we've got, if I go to the rendered view, now that we've got the verticals going, we can now look at the horizontals, the ligatures. Now what I'll do is I'll just quickly go over to our plan view at level 0. Now in this case, actually, let me go to the render view and I first tell you why I'm going to use, in this case, rebar groups as opposed to rebar sets like we did in the rectangular columns, is if I pick a crossing bar and I select a R10 tie and I select a class of 5 and then a target spacing of 2, and let's just keep that as default. Okay, then what I can do is I can hover over the column and say okay, and it will give us a ligature very nicely. But the first thing you notice is it's got a bit of a step down here, like something is happening there. It actually affects the rebar shape. If we go and click on this and we say, okay, let's introduce the proper splitter on this. And the splitter I'm going to introduce is our normal lapping splitter for that bar diameter. And I'll just hover over an edge here. You can see it does a pretty good job of splitting the bar and lapping the bar. But again, we're dealing with this kink here. It's almost like a crank rather than a proper leak. And it does affect the shape of the bar. If we go to the shape manager, if we click on that bar and go to the shape manager, if we look at it, it's a really funny shape that it creates. It's not like the rebar groups. I'm not quite sure if this is just visual or is this an actual issue. So I sort of refrain from using this. The other problem that I have with this is if we go to this bar, now that we have the lap defined, if we go to an end modifier, and we pick 180 degree and we hover over this side, the expectation would be that it will put a hook on the top bar. If I click here now, it actually does the opposite side. And if I click here, it does the opposite side. But again, you can see that it's actually deforming the bar quite a bit. So I'm not quite sure if that's just a visual or it certainly, I'm sort of a believer if it doesn't look right, it's probably not right. So I'm going to take that and delete that and not use rebar sets for these circular bars. So what I'm going to do is go over to our plan view. I'm going to go to rebar groups, and under rebar groups, the other thing that I forgot to mention is that with the rebar sets, you can't convert. Actually, let me show you. If I go back to let's just finish that properly. And I undo to get those back. If I click on these, there's no option to actually turn that set into a spiral. Um, so that is probably the major problem with this is you've got limited use in terms of a circular bar. So what I'm going to do is I'm going to delete that. I'm going to head over to our plan. And in here, what I'm going to do is I'm going to go to the rebar groups and I'm going to go to the circular bar group. And I am going to pick from the catalog a R10 tie. The class is 5, that's good. Now immediately here you can see under the group type, you've got a normal and you've got a spiral. And also under the hooks, you've got an option to add a hook immediately. And once again, the on-plane setting is going to be 25. I'm just going to leave those as is and maybe make this, let's leave it minus 500 as is. And then instead of exact spacing, we're just going to say by target spacing of 200, and we'll make all the other settings now. So once we've got that, Tekla asks, pick the part to be reinforced. We'll pick the column. And then it says pick 3 points to indicate the shape of the bar. So you only need 3 points to define a circle. So that's the first point, second point, third point, as long as they're all on the circle. Now Tekla knows what the circle looks like, and now it's asking you for 2 points to indicate the range. So what I'll do is I'll use the other available point. So that's my start position. And then when I hover over the top, I'll make sure that my line is actually snapped also. And you can see the orthogonal coming up there, and you can also see the line, the vertical line is blue. And I'll just pull it up until it snaps. And just like that, we've got our circular bars in. Now at the moment, if I click on this bar, and just hover around, you can see this was the start of the bar because that was the first node I put in. That was the second node, third node, and that is the start of the range. So start of the bar, it says there that it's got a 0 start because there's no extra here, and the end of the bar, it's got an extra 500. Now, if you want to balance that over the start point, what you could do is you could go to the start and say, I'm going to make this. Now, for a 10 bar, we only need about 450 covers. So if we go minus 225 as a start, and we go minus 225 at the end, and we say modify, we then get that 450 millimeter lap nicely centered about that start point. Now, why is that important? Is I started this bar because that was the start of my vertical, and if I balance that lap over the start, I also get that this ends nicely at that bar and this ends nicely at that bar. So if I want to put a hook, I won't have an issue. But before we put on the hook, let's just get the spacing right so it actually wraps around. So if we go in here, you can see at the moment we've got 0. So if I click on that, the start is at the bottom. So at the bottom, the front plane setting, we're going to go 100 millimeters. And if I hit a space at the top, we want 50. So in there, we can type in 50. And if we then say modify, it pulls the ligatures up 100 from the bottom and 50 from the top. And that's exactly what we want. Now, all we need to do is within that scope, we need to just redefine the spacing. So if we go to the distribution method and we pick exact spacing, we can then use the value similar to what we did, or exactly the same as what we did in the rectangular columns, which is we need, now this is spacing value. So if we want 10 bars, we need 9 spaces times 100. If I enter that, we get our lap configuration. And then if my memory serves me correctly, we add 8 times 200 for our middle zone, which gives us that. And then lastly, space, we've got 3 spacings at 50 for our top. And just like that, we've replicated what we've got in the rectangular columns, but in the circular columns this time. Now, in terms of the ear that I was talking about, if I click on this bar and I go and add a hook at the front of 180 degrees and a hook at the back of 180 degrees, and I say modify, you can see how that wraps around. And if we just get a view from the top, there we go, we can see that it sort of clips that vertical. So we need a bit more lap. So if we, while we've got that selected, if we go to the lap and we change that to 250, for instance, and 250, for instance, there, that gives us a total lap of 500. We can see we then well clear, and it gives them a little bit of grace on sight, but the hook goes around that vertical bar. And this is a pretty common stirrup to use in Australia for circular columns. It's very popular. So in this case, our component is not going to give this to us unless we explode the custom component and add the ears. But in terms of a manual way of detailing, this does fine. So if we head over to our elevation, we can now, to do the top column, we can grab the single bar and the array, and also add the copy the ligatures, and we can say copy special linear, and we'll just copy in a vertical plane. Just make sure that we X, Y, 0, and we've got 3000 because we've got 3000 elevation. We say copy. That will replicate the bars in the top. Now, we do have the problem that these bars need to end. So what we can do now, and this is why I use the component here, is whatever changes we make to this bar, those will automatically have them. So if I click on this bar, the first thing I'm going to do is I'm going to move the crank away. So remember, we moved this a negative 23, so we've got to do the opposite now. So if I alternate, select those two handles, and I say right click, move special linear, and we want to move in the X direction, and this time it's positive. So if we go 23 mils, which is a bar diameter, we say move, that straightens out the bar, and as you can see, all the others straightened out. And now lastly, what we can do is we can click on the bar, and we can say we don't need this anymore. I'll click on that node, delete it, and I don't need this node anymore, delete it. Now we've got a straight bar between 2 points, and automatically all the others have updated. And now lastly, I can alternate grab this and say move linear, click on this node, and then we need to go 1050 because this slab's 200. When you want to go 50 millimeters in, that will give us 150 from the bottom. So if I click there, we get the minus 1050, 00, and that. And if I say move, you can see all the others react as well. It's as simple as that. And now with this bar, all we need to do is click on it and then say we want to hook at the end, which is a standard 90-degree hook, modify. All the others will have the same hook then. I mean, if you wanted to hook in the other direction, you can just go custom and put a negative in front of this 90, modify, and that will curve them the other way. But I prefer the outward direction, so I'll just say modify. And just like that, we've now replicated the manual column at the top, and we've adjusted the top so it ties into the roof slab nicely. So if we just kill that view, and in the rendered view, we say entire workspace, we can now see that in here we have the circular columns also defined as a custom component with a updated custom component in the top, and then with the rebar sets and an updated, well, the rebar groups rather, and single bars with the array replicated on the top and then adjusted for the top. So I hope this was helpful on how we would deal with circular bars in where custom components don't quite cut it and also rebar sets don't quite cut it. So hopefully this was useful. See you in the next video.